Hello and welcome to this video on probability tables, part of the Year 11 Mathematical Methods course here in Australia, but again, universal around the world, of course, if you've watched my other videos. My name's Darren from Maths Guru. Thank you so much for joining me. Hopefully this short video is going to be really helpful. Basically, it doesn't matter if you're in Year 11 or in Australia because this stuff is amazing. Probability is the same. You've been doing it for years. So let's just recap what a probability table is. Now, as you can see behind me, there are learning objectives, and I do that every single lesson. Why? Just so we know what we're going to do, and everything I write is visible and can be downloaded from maffsguru.com. Yes, my little corner of the interweb. Absolutely free to sign up. Lessons, VCEE questions, downloadable lesson notes. If you're doing general maths, there's summary books, and hopefully methods 1 will come soon as well. So head over there and yeah, have a look. So what are our learning objectives? Understand that we can express a Venn diagram as a probability table, also known as a Karnaugh map. Know how to construct and read a probability table to find various probabilities, and know how to use the theory to answer a range of problems. And that's the whole point, isn't it? Is to use the theory to answer a whole range of problems. Now, I'm going to recap. Well, do you need a recap? Possibly not, because if you've been to Maths Guru, you've probably watched the videos before. Hopefully, if you haven't, they are there. It's all the foundational stuff that leads into this. But we looked into the idea of what a Venn diagram is. And I'm going to draw a pretty horrible one as it stands at this moment, but there we go. What do we have here? There is my sample space. Now, the important thing here to notice is that my sample space is effectively all the numbers that are contained within. And that's going to make a little bit more sense in just a moment. So let's draw a circle here. Let's draw a horrible circle here. We'll call that event A, and we'll call that event B. Now, let's imagine I've got A as the set of numbers 1, 2, 3, 4, 5, and 6. And let's say that B is given by the set of numbers of 3, 4, 7, and 8. So I suppose my first question to you is this. What is my sample space? If I had to say epsilon, what would I put in my sample space? Well, hopefully we would include all the numbers that are there that aren't effectively repeated. So I'd have 1, 2, 3, 4, 5, 6, 7, and 8. That's my sample space. Now, the reason I'm asking this is because what I now want to think about is, well, what would not B look like? So that's basically all the numbers that are in the sample space, but not in B. So I'm going to say there, that would be 1, 2, 3, 4, 5, and 6. And what would my not A look like? We would end up with the numbers 1, 2, 3, 4, 5, 6, in this situation, 7 and 8. Now, the reason this becomes important is because in a moment, I'm going to show you that we can actually name the sections of this Venn diagram, that section there, and that section there, and that section there, as something completely different. But what I want you to realize is now, let's just draw this again. And this is something I've never really thought of before today. I've just actually accepted it. And I was sitting here earlier today going, yeah, but why? I don't fully understand why. So I've been teaching for like 947 years. I know I look good, don't I, for my age? And nope. But I was like, okay, why are the sections called the way they are? So if I was to draw this out, we would remember that we're looking for an overlap because the intersection would be 3 and 4. So I'd probably put 3 and 4 in there, and I'd have 1, 2, 3, 4, 5, and 6. And I had 3, 4, 7, and 8 there. Happy with that? Okay. Now what I want to say is, can I find a different way of expressing the numbers 1, 2, 5, and 6? You can actually call that section there A intersected with not B. And that was the bit that I was like, well, but why? I'd never really thought of it that way before. Why is it A intersected with not B? Well, if we now look at our A, and we look at the intersection of not B, what numbers do we get? Well, I'm just going to highlight them in maybe a different color. So A intersected with a not of B. So they share a 1, they share a 2, and they share a 5, and they share a 6, and OMG, that is A and the not of B. So what could the other sections be called? Well, this section here, oh, he says doing it in highlighter. Let's change that to pen. This section here, believe it or not, is actually the not of A intersected with B. And if you don't believe me, just actually look at the numbers there. And hopefully we realize that that section there is the A intersected with B. And then the outside, Well, believe it or not, that there is the nod of A intersected with a nod of B. And just putting the numbers in makes that actually like, wow. So you've probably done that before. And here I've just put a slide in for your summary notes if that's what you need to do when you download these from maffsguru.com, and you can basically put them in and